Good day everyone, we are the group 1 and we will discuss about the skeletal system. So our learning objectives are first, identify the major tissues and structures found in bones and describe their basic functions. Second, differentiate intramembranous and endochondral bone formation. Third, locate major bones involved in posture and movement. Fourth is explain the primary functions of the skeletal system. Fifth, relate proper skeletal alignment to correct posture. And lastly, recognize common skeletal disorders and basic prevention practices. So what is the skeletal system? So the skeletal system is the framework of bones that gives our body shape and support. It also protects important organs like the brain, heart, and lungs and works with our muscles to help us move. So it is made up of 206 bones in an adult human body, along with cartilage, ligaments, and joints that connect the bones together. The skeletal system protects important organs such as the brain, which is protected by the skull, and the heart and lungs, which are protected by the rib cage. It also works closely with the muscles to allow movement, helping us walk, run, sit, and do daily activities. In addition to that, the bones produce blood cells inside the bone marrow and store important minerals like calcium that keep the body strong and healthy. The major tissues and structures found in bones and their basic functions. First is bone. Bone is a hard and strong tissue that forms the framework of the body. It supports our weight, protects important organs, helps us move with muscles, produces blood cells, and store minerals like calcium. Second is cartilage. Cartilage is a smooth and flexible tissue found in areas like the nose, ears, and the ends of bones in joints. It acts as a cushion between bones and reduces friction to allow smooth movement. Third is ligaments. Ligaments are tough bands of connective tissue that connect one bone to another. So they help hold the joints together and keep them stable while allowing controlled movements. And lastly, the bursae. Bursae are small, fluid-filled sacs located around joints. They reduce friction between bones, muscles, and tendons, helping the body move more smoothly and comfortably.
Next, let's proceed to the major tissues found in bones. First, we have the compact bone. Compact bone is the hard, dense outer layer of a bone. It gives strength, support, and protection to the bone. Structure called osteons or haversian systems. Each osteon has a central canal that contains blood vessels and nerves surrounded by a layer of bones tissues called lamella. These layers are arranged in circular patterns which make the bone very strong and resistant to pressure. Next is the spongy bone. So spongy bone is the porous, lightweight inner part of a bone. It helps absorb shock and contains bone marrow that produces blood cells. Unlike compact bone, spongy bone is not solid. It has many small spaces that make it look like a sponge. These spaces contain bone marrow, which produce blood cells such as red cells, white blood cells, and platelets. The main function of spongy bone, first we have producing blood cells through bone marrow, reducing bone weight, and lastly helping absorb shock during movement.
The other important structure in bones. So first is bone marrow. Bone marrow is the soft tissue found inside bones. It produces blood cells such as red blood cells that carry oxygen, white blood cells that fight infection, and platelets that help stop bleeding. In a way, your bones are also tiny blood cell factories. Second, periosteum. Periosteum is a thin but strong outer covering of the bone. It protects the bone, provides nutrients through blood vessels, and serves as an attachment point for muscles and tendons. So when you feel bone pain from an injury, it's often the periosteum reacting. Third is endosteum. Endosteum is a thin membrane lining the inner surface of the bone. It helps in bone growth, repair, and remodeling. So bones are not dead sticks, they constantly rebuild themselves, and the endosteum plays a role in that process. So next is the cartilage. Cartilage in bones is found mainly at the ends of long bones in joints. It is smooth and flexible, reducing friction and absorbing shock when you move. Without it, bones would grind against each other. Lastly, the osteons. Osteons are tiny structural units inside compact bone. They are arranged in circular layers around small canals that carry blood vessels and nerves. Think of osteon as the microscopic building blocks that make bone strong yet slightly flexible, like reinforced concrete designed by evolution. So bones look solid and simple from the outside, but inside they are living, dynamic, and constantly maintaining themselves.
Next is bone formation, intramembranous versus endochondral. Bone formation, specifically the two ways our bones are formed, intramembranous and endochondral ossification. By the end of this, you'll understand how your bones develop and what makes these two processes different from each other. Let's start with the first type, intramembranous ossification. The word intramembranous basically means within a membrane, so in the process, bone forms directly from connective tissue, no cartilage involved. This process is responsible for forming our flat bones, like the skull and the clavicle or collarbone. It's especially important during early development when a baby's bones are first forming in the womb. Now let's move on the second type, endochondral ossification. Endo means within and chondral refers to cartilage. So this process means bones forms by replacing a cartilage model. Here's a simple way to picture it. Imagine a cartoon skeleton made of rubber. That's the cartilage. Over time, that rubber slowly gets replaced by hard bone. That's endochondral ossification. This process forms most of the long bones in our body, like the femur or thigh bone and the humerus or the upper arm bone. It's also the reason why our bones grow longer during childhood, because the cartilage at the ends of bones keeps getting replaced by new bone tissues. Now let's compare them side by side so it's easier to remember. In terms of origin, intramembranous comes from mesenchymal tissue. That's a type of connective tissue. Endochondral comes from a cartilage template. For bone type, intramembranous forms flat bones like the skull and clavicle, while endochondral forms long bones like the femur and humerus. When it comes to process, intramembranous works like this. Mesenchymal cells turn into osteoblasts, osteoid forms, and then the bone mineralizes. Endochondral works differently. A cartilage model is created first, the chondrocytes degenerate, and then bone replaces the cartilage. In terms of speed, intramembranous is actually faster, while endochondral is slower because it has more steps. For flexibility, intramembranous bones are less flexible, while endochondral bones are more flexible. And finally, for the fracture repair, intramembranous heals through direct ossification, while endochondral heals through a cartilage callus, first before becoming bone again. To sum it all up, intramembranous is flat, fast, and no cartilage needed. Endochondral is slow,
long bones, and it starts as cartilage. Thank you.
Major bones relevant to posture and office movement. First, the skull. The major bones of skull are frontal, parietal, occipital, temporal, maxilla, and mandible. The skull is made up of several bones that protects the brain from injury and form the structure of the face. It also provides attachment points for muscles used in chewing, facial expressions, and head movements. Second, the vertebral column. The major bones of vertebral column are cervical, thoracic, lumbar vertebrae, sacrum, and coccyx. The vertebral column is a stack of bones that supports the body's weight and protects the spinal cord. It allows the body to bend and twist while helping maintain upright posture and absorb shock. Third, thoracic cage. The major bones of thoracic cage are ribs and sternum. The thoracic cage consists of the ribs and sternum, which protect the hearts and lungs. It also supports the upper body and helps with breathing by expanding and contracting. Fourth, shoulder girdle. The major bones of shoulder girdle are clavicle and scapula. The shoulder girdle is made up of the clavicle and scapula connecting the arms to the body. It allows a wide range of arm movement and helps maintain proper shoulder posture.
Upper limbs. Upper limbs. Major bones. Humerus, radius, ulna, carpals, metacarpals, phalanges. Function. Enables hand and finger movements. Supports by typing and mouse use. So, the upper limbs include the arms and hands and fingers. They help us move our arms and use our hands for daily tasks like writing, typing, holding objects, and using a mouse. They allowed fine and controlled movements. Pelvic girdle. Major bones, clavicle and scapula. Function, connects arms to the body, allows arm movement by typing or writing, supports shoulder posture. So, the pelvic girdle connects the arms to the body. It helps the shoulders move so we can do activities like typing, writing, and lifting things. It also supports good shoulder posture and keeps the upper body stable. Lower limbs. Major bones. Femur, patella, tibia, fibula, and foot bones. Function. Support body weight. Maintains balance. Helps in walking and movement. So, the lower limbs include the legs and feet. They support the weight of the body and help keep balance. They are important for walking, running, standing, and moving from one place to another. The image 2 is about major bones relevant to office posture and movement. This section highlights key bones in your body and their role in good posture, especially when sitting and moving. So the skull. Bones involved frontal, parietal, occipital, temporal. So these make up the top and sides of your head. Maxilla, upper jaw, mandible, lower jaw. Roll in posture. It holds and balances your head and helps you keep your head upright. So spines. Bones involved cervical, thoracic, lumbar, sacrum, coccyx. These are all individual vertebrae stacked on on top of each other. So, roll in posture. It supports your upright posture, helps maintain the natural curve of your back, and absorbs shock when you sit and move. Shoulder girdle. Bones involved: clavicle or collarbone, scapula or shoulder blade. Roll in posture. It connects your arms to your body and helps keep your upper body in a good position. It also protects organs like your heart and lungs. Upper limbs or arms. Bones involved: humerus, radius, ulna, carpals, metacarpals, phalanges. Roll in posture. They allow to move your arm and hand, which is important to tasks like typing or reaching for things. Next is pelvis. Bones involved: ilium, ischium, pubis. These three make up the hip bone. Sacrum, the triangular bone at the base of your spine, part of the pelvis. Roll in posture. It supports your sitting posture and your torso, and it distributes your weights like to your legs, which is crucial for standing. Lower limbs. Bones involved: femur or thigh bone, patella, tibia, fibula, tarsals, metatarsals, phalanges. Roll in posture. They support your body weight when you stand and allow for balanced movement and walking.
The primary functions of the skeletal system focusing on support, protection, and movement. The skeletal system is essential for our survival. It serves as our body structure, our natural shield, and our built-in mechanism for movement. Without bones, hindi kita makatindog, hindi kita makahulag, kag hindi mangtektahan ang aton lawas. So for this part of the report, I will explain each function clearly and provide simple, everyday examples so we can better understand how these functions affect our daily lives. The first function is support. The skeleton provides a strong framework that holds up all the soft tissues of the body and maintains our shape. Without this support, our body would collapse and we wouldn't be able to stand upright. For example, when we sit or stand for long periods, ang atong likod kag ang buto sa tiil keep us steady and balanced. When we carry a bag, our bones help distribute the weight so our body remains stable. Even simple actions like maintaining good posture or standing in line rely on the skeletal system support. So support is the foundation that allows every other body system to function properly. The second function is protection. Bones serve as armor for our most important organs. The skull protects the brain, the rib cage shields the heart and lungs, and the vertebrae protect the spinal cord. To relate this in real life, think about when we accidentally bump into something hard, like a wall or a table. Kung mabunggo kita, our rib cage absorbs part of the impact so our heart and lungs aren't easily damaged. Another example is when we fall. Our skeleton helps reduce serious internal injuries by protecting the organs inside. So protection So protection ensures that even if we experience accidents or sudden impacts, our vital organs remain safe. The last function is movement. Bones act as levers and muscles pull on them to create motion. This allows us to walk, run, reach, write, lift objects, and perform all our voluntary movements. In simple daily activities like reaching for something on a high shelf, or bisan mag-write na kita notes, or even mag-wave kita sa aton nga friends. Nagaubra upod ang buto kag unod to create smooth and coordinated movement. Without bones, our muscles would have nothing to attach to, and movement wouldn't be possible. Movement shows how the skeletal and muscular system work together so we can perform both simple and complex actions every day. So in conclusion, the skeletal system plays 3 major roles that are essential to our daily lives. That is support, protection, and movement. It gives our body structure and stability, it shields our vital organs from harm, and it works together with our muscles to allow us to move. Kung wala ini nga sistema, hindi kita makalakat, makatindog, kag hindi man maprotektahan ang aton kaugalingon. Understanding these functions reminds us of how important it is to take care of our bones through proper posture, regular physical activity, and healthy habits. That ends my part of the report. Thank you and good day.
Proper skeletal alignment and posture. Proper skeletal alignment means your bones are in the correct position, so your body weight is spread evenly. This helps reduce strain on your muscles and joints and keeps natural curves of your spine healthy. When your body is properly aligned, your muscles do not have to work too hard to hold you upright. This lowers the risk of pain, injuries, and fatigue. Good posture, such as sitting and standing straight with your shoulders relaxed and your head level, helps maintain this alignment and supports overall health and balance. Roll in correct posture. Keeps the spine in its natural S-curve. Maintains the normal curves of the neck, upper back, and lower back for balance and support. Neutral pelvis to support the spine. It prevents excessive arcing or flattening of the lower back. Relaxed shoulders, elbows closed, wrists straight. It reduces tension in the neck, shoulders, and arms. Knees at 90 degrees, feet flat on the floor. It promotes stability and proper lower body alignment. Reduces muscle strain and improves comfort. It helps prevent pain, fatigue, and long-term posture problems. Prevention of workplace strain. Neck and shoulders. Avoid leaning your head forward, keeping your head aligned over your shoulders. It reduces neck and shoulder pain. Lower back. Maintaining proper spine alignment. It helps prevent lower back pain and discomfort. Wrist and hands. Keeping wrists straight and hands in a natural position reduces strain and lowers the risk of carpal tunnel problems. Joints. Evenly distributing body weight, it prevents extra pressure on joints, reducing wear and tear over time. Muscle fatigue. Good posture allows muscles to work more efficiently, helping you feel less tired during the day. Tips for proper skeletal alignment. Adjust your chair and desk. Keep your knees at a 90 degrees angle and your feet flat on the floor to support proper lower body alignment. Keep the monitor at eye level. It prevents you from bending your neck forward or looking down for long periods. Position keyboard and mouse correctly. Keep your elbows close to your body and your wrists straight to reduce strain on your arms and hands. Take regular breaks. Stand, stretch, or walk every 30 to 60 minutes to reduce stiffness and improve circulation.
Use lumbar support. Support the natural curve of your lower back to prevent slouching and reduce back pain. Common disorders in office workers. 1. Musculoskeletal disorders. Common issues: back, neck, and shoulder pain. It often caused by poor posture, long hours of sitting, or improper workstation setup. Carpal tunnel syndrome and repetitive strain injuries. It developed from repeated hand movements, awkward wrist position, or overuse of muscles and tendons. Prevention. Maintain proper posture, keeping your spine aligned and shoulders relaxed. Reduces stress on muscles and joints. Use ergonomic equipment, adjustable chairs, proper desk height, and wrist supports help keep your body in a natural position. Take regular stretch break. Stretching and moving every 30 to 60 minutes. It improves blood flow, reduces stiffness, and prevents muscle fatigue.
Beyond our bones, we have to look at cardiovascular system disorders. It might sound strange to talk about the heart in a skeletal presentation, but because our bodies aren't moving, our circulation slows down, which can lead to high blood pressure and increased heart disease risk. The fix is actually quite simple. Try to move every 30 to 60 minutes and stay hydrated to keep your blood flowing properly. Then, there's the issue of vision disorders. We've all had those days where the screen starts to look blurry. This is often called computer vision syndrome, and it's a major cause of workplace headaches. I highly recommend the 20-20-20 rule. Every 20 minutes, look at something 20 feet away for 20 seconds to give your eyes a much-needed break. We also have to consider stress-related and mental health disorders. High-pressure office environments can lead to anxiety, burnout, and even sleep problems, which actually causes our muscles to tense up and creates more physical pain. Maintaining a solid work-life balance and practicing relaxation techniques are essential for your physical and mental health or mental well-being. Finally, we have obesity and metabolic disorders. Because office work is so sedentary, our metabolism can stall, increasing the risk for weight gain and type 2 diabetes. Staying active during your breaks and eating a balanced diet are the best ways to keep your body's fuel system from slowing down. To sum up everything we have discussed today, the skeletal system is our body's essential framework, providing the support, protection, and movement we need to live. We have explored how bones form through intramembranous and endochondral ossification and how proper alignment of the spine, pelvis, and limbs is the secret to avoiding the workplace strain we just discussed. From the skull down to our lower limbs, every bone provides the stability and mobility we need for our daily tasks. Ultimately, preventing these disorders is within our control through ergonomics, regular movement, and healthy lifestyle habits. Well, that concludes our presentation. We hope this helps you to stay a bit more mindful of your posture during your next long study session. Thank you so much for listening.